Hello, my name is Francisco Flores, and welcome to my Computational Fluid Dynamics Final Project presentation. Today I'll be discussing a 3D analysis of a mobile home that you see above you. First, let's get into what CFD is and what it entails. CFD is short for Computational Fluid Dynamics, which is even shorter for a computer software that we use to perform simulations based on studies and research and different input parameters. Using numerical analysis and data to structure and analyze problems that involve the flow of a fluid. Using this computer software, we can sketch, mesh, set up, find solutions and results for all kinds of different problems that involve fluid dynamics. So some of the benefits to using a CFD program, other than spending countless hours solving math problems, are as follows. We can use it to predict the fluid flow, the heat transfer, the mass transfer, chemical reactions. We can determine if improvements are needed to reach specification standards, determine pressure drops, determine fluid dynamic forces such as lift and drag, the heat transfer rates and mass flow rates, which I mentioned earlier. And it's also really simple to input these parameters to process the numerical analysis in order to determine the solutions and results from the animations and velocity vectors and velocity contours. My problem selection is a CFD analysis on a 3D mobile home. I got this idea from Hurricane Delta, causing some damage to one of my neighbors from the strong wind gusts that were ranging from 120 miles an hour to 90 miles an hour. And it actually caused his mobile home to rotate 90 degrees basically on its side. The dimensions of this mobile home are 76 feet in length, 16 feet in width, 13 and a half feet tall. The gauge pressure the day of the storm was 97,200 pascals. Standard air properties, transit time, laminar flow was assumed along with gravity in the y-axis from the zy plane. For my methodology, you can see my sketches I used. I sketched them in the ZY plane to make extruding pretty easy. As you can see on the left bottom picture, the height and the width of the mobile home, which is 16 feet and 13 and a half feet. And then on the right hand side of the picture, you can see the actual plane, and the extrusion was the 76 feet in length. Of course, I converted everything to meters in order to be consistent with the program units. Following image is of the velocity contour results, but before we get into that, I'd like to talk about the actual setup that went in order to get these results. So before I could get these results, I had to input some parameters in the setup function of the program, where I use the double precision and 3D, obviously. Like I said, I assumed transient and laminar flow. The only thing I added was for the cell boundary, I added the air constants, and for the boundary conditions, I added the inlet speed, which at first was 120 miles an hour, and for the next one, after this was 90 miles an hour. Also, I assumed 9.8 meters per second for gravity and 97,200 pascals for the gauge pressure that day. After that, I went to monitors and to residuals and changed my numbers to 1e to the negative 0.5. And then I went to initialization and clicked on input, and all my boundary conditions appeared. Then for my run calculations, I put 0.01 for step time, and I ran 250 steps with the 50-step max. And voila, after that, I ran the velocity contour for the first 120 mile an hour wind, and that is this image in front of you. For this velocity contour result, I assume the 90 mile an hour winds. As you can see, the bright red center is the same. However, the only difference is on the left-hand side of the image. The range changed. I think the max on the last slide was 6, and this one is 5.37. However, the velocity contour is pretty similar. It's still catastrophic, and obviously all the focus is on that wall of the mobile home, which caused it to rotate 90 degrees, as you will see in the next few slides. The following velocity vector results are from the 120 mile an hour wind simulation that I ran. As you can see, the center of the mobile home is probably where most of the velocity is going. It's, I'd say, bright orange, or not bright orange, burnt orange to yellow, ranging from 5.95 to 5.20. And this velocity vector result, I use the 90 mile an hour wind gust in order to determine that the range is slightly lower. However, the colors remain the same. I'd say this one ranges from 4.22 to 4.5. And here is the actual inspiration that I got from the problem. The picture is taken in Sabine Pass, about 2 blocks from my house. The mobile home was actually up on a hill, and it's not a very big hill, as you can see, maybe 5 steps or so. And that mobile home used to connect to the steps, and you just can't even imagine how strong the winds must have been going in order to make a whole mobile home flip over. And unfortunately, I had another neighbor that had a similar situation, but with an RV. It was actually facing the same direction as the mobile home and flipped, 90 degrees, just like the other one, except this one's a RV. This will conclude my final CFD presentation and analysis on a 3D mobile home. I hope you enjoyed it and learned something from it like I did. Thank you, and have a good afternoon.